Today we will be studying laws of exponents for real numbers. Let a be a real number greater than 0 and p and q are rational numbers. Then a raised to p times a raised to q is equal to a raised to p plus q. We know in a raised to p, a is the base and p is the exponent. In a raised to q, a is the base and q is the exponent. A raised to p times a raised to q. A raised to p is the multiplier and a raised to q is the multiplicand. Both multiplier and multiplicand both have the same base, so the exponents are added. A raised to p times a raised to q is equal to a raised to p plus q. See this example, 2 raised to 3 over 2 times 2 raised to 1 over 5. Here instead of a we have 2, instead of p we have 3 over 2 and instead of q we have 1 over 5. So the result is 2 raised to 3 over 2 plus 1 over 5. So we have to add 3 over 2 plus 1 over 5. The LCM of 2 and 5 is 10. So 3 over 2 is equal to 15 over 10 and 1 over 5 is equal to 2 over 10. So 15 and 2 are added, resulting in 17. So the net result is 2 raised to 17 over 10. Next is a raised to p, the whole raised to q is equal to a raised to pq. A raised to p, the whole raised to q is equal to a raised to pq. And we have to remember this result also. 1 by a raised to n, 1 upon a raised to n is defined as a raised to minus n, or a raised to minus n is equal to 1 by a raised to n. So a raised to minus n is a notation for 1 by a raised to n. See this example, 1 upon 3 raised to 3, the whole raised to 7. 1 by 3 raised to 3 is equal to 3 raised to minus 3. So 1 by 3 raised to 3, the whole raised to 7 is equal to 3 raised to minus 3, the whole raised to 7. It is of the form a raised to p, the whole raised to q. Instead of a we have 3, instead of p we have negative 3, instead of q we have 7. A raised to p, the whole raised to q, which is equal to a raised to pq. So minus 3, negative 3 and 7 are multiplied, resulting in negative 21. So the result is 3 raised to negative 21. We know 3 raised to negative 21 is equal to 1 upon 3 raised to 21. Next is a raised to p upon a raised to q. A raised to p upon a raised to q. Here a raised to p is the dividend, a raised to q is the divisor. Both dividend and divisor are having the same base, so we have to subtract the exponent of the divisor from the exponent of the dividend. So the result is a raised to p minus q. A raised to p upon a raised to q is equal to a raised to p minus q. See this example, 11 raised to 1 over 2 upon 11 raised to 1 upon 4. This is of the form a raised to p upon a raised to q. Instead of a we have 11, instead of p we have 1 over 2, instead of q we have 1 upon 4. The result is a raised to p minus q. We know 1 upon 2 minus 1 upon 4. The result is 1 upon 4. So the net result is 11 the whole raised to 1 upon 4. Next is a raised to p times b raised to p. A raised to p is the multiplier, b raised to p is the multiplicand. So both the multiplier and multiplicand have the same exponent. So base can be multiplied together because a and b both have the same power. So the result is ab the whole raised to p. A raised to p times b raised to p is equal to ab the whole raised to p. So an example is this: 7 raised to 1 over 2 times 8 raised to 1 over 2 is equal to 7 into 8 the whole raised to 1 over 2. Instead of a we have 7, instead of b we have 8, and instead of p we have 1 over 2. Both 7 and 8 have the same exponent. So 7 times 8 is 56. So the result is 56 the whole raised to 1 over 2. We will be practicing some more problems. We have to find 32 raised to 1 upon 5. We know that 32 is equal to 2 raised to 5. So 32 raised to 1 upon 5 is equal to 2 raised to 5 the whole raised to 1 upon 5. Now this is of the form a raised to p the whole raised to q, which is equal to a raised to pq. A is 2, p is 5 and q is 1 upon 5. A raised to pq. 5 and 5 will get cancelled and we will be getting 2 raised to 1, which is equal to 2. Next is 16 raised to 3 upon 4. We know that 16 is equal to 2 raised to 4. Therefore 16 raised to 3 upon 4 is equal to 2 raised to 4 the whole raised to 3 upon 4. This is of the form a raised to p the whole raised to q. A is equal to 2, p is equal to 4 and q is equal to 3 upon 4. It is of the form a raised to p the whole raised to q, which is equal to a raised to pq. So 2 raised to 4 times 3 over 4, a raised to pq. This 4 and 4 will get cancelled, resulting in 2 to the power 3. 2 to the power 3 is equal to 8. So the result is 8. The next is 125 raised to minus 1 upon 3. We know that 125 is equal to 5 raised to 3. So 125 raised to minus 1 upon 3 is equal to 5 raised to 3 the whole raised to minus 1 upon 3. This is of the form a raised to p the whole raised to q, which is equal to a raised to pq. Instead of a we have 5, instead of p we have 3, and instead of q we have minus 1 upon negative 1 upon 3. A is equal to 5, p is equal to 3 and q is equal to negative 1 upon 3. This is so a raised to p the whole raised to q is equal to a raised to pq. So 5 raised to 3 times minus 1 upon 3. This 3 and 3 will get cancelled, resulting in 5 raised to minus 1, which is equal to 1 upon 5. Please remember this result. This is a very important result. Square root of nth root of a raised to m, nth root of a raised to m, which is equal to a raised to m upon n. Nth root of a raised to m, nth root of a raised to m is equal to a raised to m upon n. Remember this also, a raised to 0 is equal to 1. Why? A is equal to a. Divide both sides by a. We get a raised to 1 minus 1, which is 0. And here a and a will get cancelled, resulting in 1. So a raised to 0, any number raised to 0 is equal to 1. So we are closing the module 1.6 here. So the first chapter is finished. We will be continuing with the second chapter.